For those of you who are here getting your master's degree in home performance on YouTube, I have a resource that I think is very available. It's very free. It just depends on you doing a little bit of legwork to find more stuff than just you could see in the videos that those of us who are doing videos in this space are deciding to make about certain topics. You need to know what you need to know at certain times. You got to have that information right now. And there are checklists that are available for you. So I'm going to go through 4 of them. I found this one that I really wanted to talk about. And then I was like, you know what? Let's just make a video about how you can use these checklists. And I have a specific client in mind that I want to just tell you about briefly, and this might be you. But basically, if you go online, you search around for checklists for whatever. If you're building a treehouse, checklist for treehouse structural stability. You just search that term and see what pops up. Now that we've got AI that can also do searches for us, you could just ask their advice too. But if you can't find a local professional who's willing to guide you and teach you some of this stuff, and I think that's one of the things that you're actually going to get points for in these checklists, that teaching ability is not always going to be there with the contractor you're working for or working with, or with the locals who are going to be in the building industry. They just might not have the time or the inclination to be able to give you advice. And we all need that advice. So we're going to begin here with this HVAC installation. And the client that I specifically was like, you know what, I got to talk about this more, started out the conversation with me by saying, we decided to GC our own build. That means general contract. That means you're in charge of the budgeting and the scheduling, hiring everybody, making sure they show up on time, making sure the materials are there, etc. And I don't know anything about this. And in this case, she, like many women, think you have to be more qualified than you actually do to do this stuff. I'm a perfect example of this. I'm not very qualified to do a lot of the things that I end up doing in building, but it's not that scary. You go online, you find somebody who knows what you're talking about, you hire them at their hourly rate, or you watch some videos if you've got more time to spare, and that's all that it is. So these checklists will get you in the neighborhood of at least the questions to ask. And then if you get the answers that you're looking for, then that's good. So here's your first one. This is from ACA, which is the Air Conditioning Contractors of America. Again, this is a free checklist, and I will be linking all of these in the description below. So this is referencing the HVAC quality installation specification, which you can see right here. And this checklist is just a brief way to kind of assess whether somebody's going to be following this. So the idea here is that this is used by you, normal person, not a contractor, to assign each contractor who's giving you a bid a number of points. And then you divide their total price by the number of points that they're going to be giving you. And then you can kind of grade them on price per point. And you want to hire the contractor who's giving you the best price per point, not the one who's giving you the best price. Because if you get somebody who's not going to do any of the things on this list, but they're the cheapest one, that's actually super expensive in the long run because they're not doing any of this stuff. They're just charging you money for what exactly? You have a box, then you have a box that cools supposedly. That has to be hooked up to ducts, has to be hooked onto a house. All those things kind of require further analysis. So before installation, you can see over here on the left, did the contractor review the load calculation with you? I would say that this is a great first place to start because one of the differences between what I do as an HVAC designer and what other people, even who you follow online, is that I will take the time, I insist that I take the time to explain what is in the load calculation to my clients. Most people are not willing to do this first step. And I would say that if there's one piece of advice and then you stop watching, if you're a professional, you're watching this right now, to kind of get tips on oh, how is this guy talking to his clients? I would say just explain things. People are not dumb. If you take the time to explain the math, most people will be like, oh my God, not only do I appreciate this moment, but also I'm never hiring anyone else again who could do what you do because you're now a totally different class of professional in my mind. You're not a contractor. You're some other thing. And also, if people need to hire a painter, I used to get calls from my clients be like, hey, I know you don't do this, but do you have anybody that you would refer? Because I trust what you say. So that's we got to make more of that trust back and forth. So they should review the load calculation. By the way, double points for a room by room load calculation. And that's the one that you should be asking for. Did the contractor review the manufacturer's performance data with you to demonstrate why the unit you're buying is the right size? So not only do you do the manual J, which stands for joule, it's the amount of heat and cool that any home needs on the peak conditions, but then we pick a piece of equipment based on that. If you didn't do that, you can't pick a piece of equipment. So if somebody did not do a manual J, and a room by room, I would say, is like generally the one that you want, they can't possibly pick a piece of equipment for you. And you can't pick a piece of equipment for you. You can't just say, oh, well, there's a 5-ton in my house now, we should just replace it with a like size. That doesn't make any sense. So this is always very important, knowing why you're choosing and paying for the piece of equipment that you're buying. And also then, did they present proof that the system will deliver on the specified efficiency? And by the way, we're going to get more into the system aspect of this because, of course, everything is a system. Just the box that cools or heats isn't really the whole conversation. By the way, 2 points for providing the manufacturer's performance data. And that is something that is not available to just anyone. You have to, this is called the OEM extended performance data. So this is basically a giant table that shows you at different outdoor temperatures and different indoor temperatures and humidities, what the unit actually puts out. Because if it says it's a 3-ton unit, that does not mean that it delivers 36,000 BTUs of cooling at any temperature outside and at any temperature inside, or that it delivers 36,000 BTUs of heating, if it's a heat pump unit, at any temperature outside and any set point inside. All that stuff is wildly variable. And also, how long is the pipe that carries the refrigerant, and how many 90-degree turns does it take, and et cetera, et cetera. So there's a whole bunch of extra stuff that goes into calculating why a piece of equipment is the right choice for this particular load. And that's just important to talk about. So did they do that? Points. Did the contractor review the condition of your duct system with you? This is during installation, right? So you've signed, and by the way, you use this beforehand. You say, okay, during installation, are you going to review the quality of the duct system? And if they're like, no, great, no points. And also, I'm like, you're probably not going to be very good at explaining any of the rest of the stuff to me. Did they review the condition of your current venting system? So if you have a furnace and you're replacing it with another furnace, did we look at the venting system, the chimney? It's called a flue that goes up through the top of the house, because there might be problems with that. I test this a lot in homes when I go out and do on-site testing, and I often will find that the venting system is either not adequate now, or now that my client, which just happened literally 2 weeks ago, now that my client has installed a kitchen exhaust hood, which is something you want, and it goes outside and it pulls maybe 600 CFM, which is this particular client that I'm thinking of. Now the venting system is not adequate. Now we're spilling combustion gases from the water heaters into the basement. So those kinds of things, this system thinking is very important. Will the contractor measure and document the airflow? Do they have the tool to do that? Do they have the training to be able to do that? Do they even know that that matters? And if they say, no, or if they say, oh, excellent question, no, we're not going to, but it's for a very specific reason, I think that kind of gives a half a point. If somebody says, like, for example, room by room load calculation, in the case of a replacement where the duct system is like welded in place, solid metal, insulated, no problems, no disconnections or anything like that, I often will say, you know what, let's leave the duct system. That's a good duct system. So now at this point, it doesn't even matter what the room by room load calculation is, because we're not going to mess with the duct system. Like, if we find out that it's off, we're not replacing it anyway. So just knowing information that makes you feel sad doesn't help anybody necessarily. So kind of that's another way to grade this point system. Will the contractor measure the refrigerant charge? And measure often means, like, a piece of equipment comes with a certain amount of refrigerant built into it, and that's poundage. Like, you don't have to take it out of the equipment and weigh it, but that is how you would do it if I was coming to your house and your system had been installed for 10 years. We actually evacuate all of the refrigerant into a tank, weigh the tank, and then say, oh, that's how much there is in the system. And we put it all back, all minus a little bit that bleeds out. So every time you tap into that refrigerant system, you're stealing a little bit. So over time, that is going to add up. Will the contractor ensure the unit is safe electrically? Like, what does that even mean? And this is where some of these questions that we're going to go through in these checklists are like, what exactly does that mean? It's kind of interesting. Will the contractor test the firing rate of the new furnace or boiler? This is like clocking the meter. So you go outside, you look at the gas meter while the thing is firing, and you measure how much it's actually consuming. You could also do a pressure test on the manifold and see what the gas pressure is coming out, and then you kind of tune it. So this tuning, like taking your car to a shop. My previous partner, John Bergman, took his car into the shop because the horn wasn't working. And the guy said, "Oh, we're going to run some tests." And he was like, "Oh, great. I love tests." And the guy said, "Oh, yeah, we ran the test." He was like, "What was the result of that test?" He was like, "Yeah, the horn doesn't work." That's not really a test. That is just, I don't know what that is. But anyway, that's not what we're talking about here. Ensuring the unit is safe electrically means running some kind of a diagnostic on it, and making sure that you provide data on like the fuses that you used and blah, blah, blah. Will the contractor test the firing rate? We already went over that. Test the venting system. Test the draft pressure inside the flue. Test the combustion analysis, right? And that's what they're saying here. 2 points for a combustion analysis. And a combustion analysis often will include a carbon monoxide test, which is testing the venting system for what the combustion gases are made of. So that's, again, you can get a bunch of points for that. Almost nobody is going to do that. So if you find somebody who does, great. That's the person you want to work with. Will the contractor test the thermostat? This is kind of interesting. So we tested it and it works, or we tested it and it doesn't work. How exactly does it work or does it not work? I have seen thermostats that are literally 8 degrees off calibration from reality. And nobody knew until I showed up and took a thermometer that I know is realistic and put it right next to the thermostat and for 10 minutes and let it sit there and said, yep, this thing is like, it says that it's 75 in here, but really it's 68 in the room. Like, that doesn't make any sense. So how are you testing it, and what are you testing that it works for, I think is an important question. And that is, again, this is like a conversation starter, this checklist. So this is not an exhaustive list. If the ducts are new or to be repaired, did the contractor state how they will measure the duct leakage after the repairs? Either they or a third party. And you can always bring in a third party yourself and just say, hey, I'm going to have somebody else come in and test just to make sure that we're hitting these metrics. That might make some contractors nervous, might make some of them upset enough that they just walk away because they don't know what they're actually able to deliver. That happens a lot. So it's possible that with this checklist, you are going to be getting rid of some of the people who are on your list. They're just not going to want to work for you because you're asking too many questions. That's not the person you want to work with anyway. Will the contractor test the amount of air and or water flow into each room? That takes another kind of tool that wasn't the system airflow that we talked about above. This is something else. And if they say, no, I'm not going to, but here's why. Again, I think that that's like an interesting, this is all just kind of conversation starters. After installation, will the contractor provide a copy of the installation checklist with a record of all measurements taken? I can't even tell you how many times I've heard of people who do what I do, comprehensive home performance testing, blower door test, duct tightness test, infrared, and they don't give a report, or they give a report, but it's like a month or 2 months after they were there. And it's not complete at that point. Like, you can't, I give a 1 week turnaround just because I need to go back and do some other stuff. But like, if you wait long enough, I forgot what the house was like, because like, if I'm working, I should be seeing a bunch of houses every week. And so anyway, you need a report of some kind, a record of the pictures. Somebody took an infrared picture, but then they didn't give it to you. I don't think that doesn't sound like a really solid service to me. So they should be providing some kind of a report, even if it's handwritten. Will they provide a copy of owner's manuals, manufacturer's warranty, and their own warranty? This is all like easy stuff. Recommended maintenance also. It should be kind of like, that's not that hard. And by the way, it also goes to references. You should be finding references, like you should be getting these people's names from online sources. Like ours, by the way, I've got a list of scientific-minded HVAC professionals on our homediagnosis.tv website. I'm linking it on screen right now. That's one place where you can get lists. I will say that list, I don't vouch for everybody on that list. That's an honor system list. And often you'll find somebody who had a great experience with one company, and then the next person had a terrible experience with them. And like, everybody has that happen. And that's why you want multiple. So call the references if they give them to you. Also, ask for the mechanical license. And if they say, oh yeah, we're licensed, but I can't give it to you, look them up. There's a state website in every state for looking up whether somebody's license is current. Your business license, your insurance, need that, and bonding. So those things you want to just like ask for. And again, this is stuff that like, just like in if we went grocery shopping, you assume that your food is not poisoned. And more these days, that's not true. And go check the FDA's food recall list if you are not aware of what's happening right now with deregulation and all this stuff. But knowing that your contractor is insured is not the same thing as having the certificate that shows that they are. So anybody can say, oh yeah, we're insured. And often people will find out after, like, oh, actually you weren't insured for this, what you did today, that's not insured. Or we didn't pull a permit, so it's actually not going to be covered by insurance, or whatever it is. And so permits are also in here. So then you divide, if somebody's charging you $10,000 for this job, but they're delivering 20 points, you're getting $500 per point. That's amazing. Good job. Hire that person. So you just use this, and it all, again, refers back to this HVAC quality installation specification, which is how you install this stuff so that it'll deliver to every room within 2 degrees, let's say, of the set point on the thermostat. Those are things that are very possible. So it's not true that every home has problems. It's like often stuff within the system gets overlooked. So it's then got these key terms at the end and help finding contractors and blah, blah, blah. I find this to be a super helpful checklist. Let's move on. So this is from Foundations. And what I like here is that it says, the following items are to be reviewed for completion by the contractor or owner prior to scheduling an inspection. In general, that is what you're going to see within these. And this one, by the way, comes from the Nevada County Building Department. So whenever a building department is posting one of these checklists, it's for you. It's for literally the audience of this video before you call for an inspection. So this is not what contractors are trained to do. Like, this is not necessarily for the inspector even. This is what we're using it for today. And so they're out there. Like, this is, again, Nevada County Building Department. Can you find one from like a million other counties? Yeah, probably. So it's intended as a guide and not an all-inclusive list. And you will see how this works here. So basically, general notes here. Okay or not applicable, and everything should be okay. There is no checklist for like, oh, no, this is not right, because you just work on it until it is right. A whole bunch of stuff at the top here that's administrative for the inspector. Animals are restrained. It's safe to walk around. There's tape where it needs to be. There's signs where it needs to be, blah, blah, blah. None of that stuff is necessarily for you. So here we get down to the bottom of the first page. You can see concrete being placed during freezing or near freezing weather shall comply with cold weather concrete construction requirements. This is, again, before you call for inspection. So the concrete hasn't been installed yet. You're calling for this inspection when the rebar is in place, when you're like ready to install the concrete. I will tell you that right here, there's an admixture, which is just a powder that they can add to concrete to mix in, that is for freezing conditions. It's like it changes the freezing temperature of the concrete, I believe. And so we had to use that. And I found out that actually, that did not get added after they had already started pouring. I'm looking at the sheet. So you got to look at the sheet that comes from the concrete factory where they poured this stuff into the concrete truck, and review what's on there too. So your job does not end with like making sure that the checklist is filled out. You got to keep this level of vigilance all the way through. Tend to the area with approved blankets. What are approved blankets? I don't know. So that's a question that you should ask. And the contractor might often say, they'll either say, I don't know, blankets? Or they'll say, oh, that is a reference to this code and blah, blah, blah. Or like, we talk about this is heated blankets that have this amount of BTU per square foot or whatever it is. So again, conversation starters. The ground shall be thawed and inspected. Interesting. That means you have to wait, basically. Or you have to use heaters. And that's often used. If you're using a tent and you have a heater, great, you can thaw it on purpose, even though the rest of the area around is frozen. Temperature gauge shall be on at all times while concrete is curing for 72 hours, blah, blah, blah. This is the kind of stuff. What kind of temperature gauge? How deep are we measuring this? This is the conversation that you're having with your contractor. Concrete being placed during hot weather shall not undergo excessive concrete temperatures or water evaporation, right? So concrete can get too hot as well as too cold. And you just want to talk about how are we going to do this? And if they say, don't worry about it, I've been doing this for 50 years, I never have any problems. That is not the answer to this question. So that guy is not the guy that you're looking for. Setbacks, again, this is administrative stuff for zoning. Don't worry about it. Grading and pad creation. Compaction reports shall be on site for any building, pad, grading, or fill. I am not aware that I was offered a compaction report. Now, I ran the compactor on my site. I was the general on our and the builder on our project. So maybe this is something that general contractors do all the time, but I'm pretty sure that you'll meet plenty of them who say, yeah, I don't really know what that is. It might be one piece of paper. Like if I gave you a napkin that said compaction report, giant check mark, is that a compaction report? Like what are we looking for here? Review the soils report. Who does that? Is it a geotechnical engineer? If you have looked into it, you might be aware that geotechnical engineers, who I had one of on our build, and you can see him in our videos online, just search geotechnical on our channel, but you won't find, he's one guy in all of Atlanta. You might live in the middle of some place that doesn't have any that are willing to work on residential projects because they're just so busy doing commercial projects or industrial projects. So maybe you can't get that. How important is it? I don't know. Again, conversation starters. Footing depths. You got this like local code that says what the freeze depth is, and it needs to be at least 12 inches below the site's frost depth. If the stem wall height is this height, you need to be at least this deep, so 6-inch thickness. If you're this high, you need to be at least 8-inch thick. Ours are 8-inch thick for our stem wall in our crawl space, which is only a 4-foot crawl space. But we heard from the contractor that they always, just blanket statement, they always do 24-inch wide footers that are 12 inches deep, and then they do 12-inch foundation walls. That's just what they do on every single house. And this is where the value engineering, like trying to engineer cost and efficiency at the same time, is very important because you can't just go over budget on every single house. And I find that many people end up doing that because it's like, oh, well, if silver is good, gold is better. I want to go for gold. Like, you can't go for gold on every single thing. So using these to figure out what you need to do. Rebar, grade and strength and engineering and all that stuff, making sure that your laps and your splices and your hooks are all per plan if you've got a plan, or if you don't have a plan, you're following the prescriptive requirements within your local code. And finding out what that local code is, getting a copy of it, that might be difficult depending on how transparent your local code department is. 3-inch minimum clearance to earth, 1.5-inch minimum clearance to forms, 3/4-inch minimum clearance to air. Like, you're walking around with a tape measure at that point, or like a little jig that's got these measurements on it. Checking all this stuff. That's how you do this. So making sure that you've got all that. And are you going to find mistakes? Yes. There will be, someone has to do this inspection job. And what I find more and more as we go deeper into, deporting a lot of people who are working on these job sites, or not paying them what they're worth, or making them, these jobs are just for kids who aren't smart enough to get into liberal arts college. Like, all that stuff is so dumb. There's not a guy who's doing this inspection if you're not doing it. So, in most cases. So if you find a contractor who's actually got a quality control person who's going to be on your small residential site working on this stuff, that's amazing. Not normal. All reinforcement is secured against displacement when walked on. Or are there going to be tractors driving around your site? Yeah, there are. At the very least, a skid steer that's going around and placing rock and things like that. So is that going to be moving this stuff over here? It probably might. And so you want to check this multiple times. Even after the inspection, when somebody comes to fix just one more thing, or during the fixes to the inspection, again, they're gonna find stuff. Reinforcement is clean of loose scale, rust, ice, mud, oil, etc. I found a lot of mud all over my rebar, and so I cleaned it. And I cleaned it with something that was purple colored. You're not supposed to do that. Water is just fine. So but going around and cleaning this rebar. And people will say we've got this concrete video that's like 26 minutes long, me talking about concrete the day before we poured it. And people will say all the time, your contractor should have known this stuff. I'm like, that's very cool for somebody who's been doing it for 75,000 years to say that and be all jocular about it. But really, all of us are learning this stuff all the time. And if you really think that you go onto every job site and you do a perfect job every single time, I don't know what planet you live on. I do less good of a job on job sites where I am less important because I don't have to bring 100% of my brain to this. We're talking about where the bath fan should go. It's a simple answer. In the shower. Which way should it point? The way that's easiest for the airflow. It's I don't even have to really think to say those things. And then it's like, oh, well, we've got this little problem. Great, turn your brain on for 20% just to be like, oh, yeah, just do this. So like we all do this every day. So making sure that somebody's bringing a full brain to this. And I think often beginners are good at that because you're not assuming that you know what's going on all the time. So footing elevation, right? Minimum of 12 inches below frost and 6-inch minimum drainage fall up to 10 feet away from the house, right? This is really important about controlling water. This is going to come up again. This is something that's a grading question. And I've got a client who's a member of our Patreon group, and our Patreon group is amazing. His name is Daniel, and he hired one of his buddies to come in and do some extra grading work because there was like a lot of dirt in a place that he didn't want it like during construction. So he had his friend come in and do that, not as part of the building team, and then it led to like some side effects down the road. Those are the kinds of things always happening on build sites. Like today, our roof shingles got delivered a month early for some reason because they just said, oh, we can get this to you early. And then nobody said, don't do that. So now we've got these roof shingles sitting here and I have to put them in a place that now it's interfering with the flow of this. So then I had a tractor move them over there. Things are changing every day. Mistakes are made. Trenches are clean and free of debris and soil is properly conditioned. What does that mean? Again, asking the questions. The hold down straps and the bolts and minimum diameter of the bolts themselves. By the way, you can wet set these at time of concrete placement, but you can't do things like down here when you're installing your slab. You're not allowed to be pulled up. So like there was this thing that my contractor, who was a good guy. I really liked working with him. But he said, what we normally do is we lay the rebar down there. We don't put them on little feet. And then when we're pouring, you just take a piece of rebar, which is shaped like a hook, and you take it down there and you lift the rebar up as it's in concrete so that then it sits inside the concrete. And I'm not saying that they don't know how to do that well, that might not work, but like the amount of risk on the day of when there's a lot of stuff happening and there's people yelling and there's a giant concrete pump truck and there's like moving parts, your risk of doing something wrong at that moment is pretty high. So that's why these checklists exist. Is like, make sure you've done these things and that you're not just going to wing it on the day of because your risk of failure is greatly increased. Okay, so per plan, blah, blah, blah. Reinforcement is secured in place. By the way, one thing that I didn't know about rebar is that you've got these little chairs that you can get at like the big box stores that are metal. But if they corrode and then they're tied with metal wire to the rebar, the whole thing can corrode inside of your, and like I'm not saying that this is a major problem for houses because low load, it's not a bridge, people aren't driving over it all day long, and it's small. But is it better to have plastic chairs? Yeah, it is. Did I know that those even existed when I poured? Like, no, I didn't. So you can get those. You can't get them at the stupid big box stores because the only thing the big box store sells is stuff that people will buy today, right now. Lots of people, not just one person. So are they going to have the good stuff? Probably not. So again, knowing that it even exists is good. Also, something I forgot is grounding electrode. You could either drive a 10-foot long piece of metal, 3 of them, into your yard and then wire them together and hook them up to your electrical, or you could bury this thing in the concrete, and this is a smarter way to do this. So I didn't even know that was a thing until way too late, and then my electricians installed it for me instead. So all of this is like, it's a good education in what I don't know. Do I know how to fill out every single thing on this thing? If I don't know something, I go online and I start learning more about it. That's the way to use it. Okay, next is framing checklist. So this is from the city of Austin. Again, it says this is provided as a reference tool and is not intended to be exhausted. By the way, check this out. Please refer to the latest adopted International Building Code, International Residential Code, International Energy Conservation Code, International Swimming Pool and Spa Code, Uniform Plumbing Code, Uniform Mechanical Code, National Electrical Code, da-da-da-da-da-da. Do you really think that your contractor, let alone the code official who's supposed to be enforcing all this stuff, really knows all these codes by heart? They do not. They have books, if they're lucky, that they can refer to in their library and go back and remember, like, I need to look up 402.3.4 in the UPC just to make sure that this thing is right, that I was thinking, because my dad taught me this, and I think that he was right, but let's just double check. So these things are really important to check because there's just so much information out there. Please verify before calling for the framing inspection. Number one, that everybody's ready and blah, 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 the job address. All exterior windows, penetrations, and openings have been sealed. That sounds a lot like a perfectly airtight house, doesn't it? What exactly do they mean by that? So again, you use this beforehand, before you even hire your framer. You're just like, hey, here's my checklist that I'm going to use while we work together. How are you going to seal all exterior windows, penetrations, and openings? And if they say, oh, we don't do that, the insulator does that. Great, now I need to go talk to the insulator and be like, how are you going to do this? And they say, oh, we don't do that, the framing guys do that. So again, there's a guy who does this stuff. It's you. So saying, here's what I want, or making your draftsperson or your architect put this in the specs and details. Here is how we are going to do this, because I saw on Matt Reisinger's channel or on the Build Network in general, or I saw, whoever talked about whatever ceiling that I like. I'm going to build that into my plans. And you can what I like about this one is that it's referring to the code specific code language. That's IRC, stands for International Residential Code. Chimney terminations are this high next to other buildings, or this high from your own roof, etc. Concrete and masonry foundation walls extend above the finished grade at least 4 inches. And that means that then if we're going to do something like I did of exterior insulation on my foundation wall, I have to cover that somehow so I don't have weed whacker eating away at my insulation all the time, or bugs or animals. And by the way, that's a constant source of interest for my clients, because there's no building material that's warranted to go underground. So, and you're going to have to kind of like put it all the way on the face of the insulation. Anyway, digression. The grade at the foundation walls falls away from the building at least 6 inches within the first 10 feet. This is a framing inspection. This is not foundation inspection, but we have this item on both checklists. It's because it's so freaking important. No joke. If you don't do this right, whatever you've done to the foundation wall doesn't matter so much. And also, you could get away with a lot less work on your foundation wall waterproofing if you do this right. So taking this really seriously, putting on as many checklists as possible is good. And reminding yourself that stuff changes. We had to dig to do something to the French drain system or whatever, and then this condition changed. And so now I need to remember to go back and revisit that and fix it again so that we can move on. A controlled method of water disposal from roofs is in place. Now, this is something where, in my case, my house doesn't have this. I don't have gutters on my house because I didn't want them. I see how much work my dad puts into his gutter system and maintaining that. My grading is extreme. So it's not 6 inches per 10 feet. It's 6 feet in 10 feet. So I don't have to worry about that. And I've also got longer eaves, and so the rain goes where I know where the rain goes, and I know what happens to it. So just knowing what is going to happen is kind of what we're talking about here. Exterior doors have landings. This is something I didn't know about until after I built our front porch, and I was like, okay, great, here's what I want to do with the deck. And then the guy said, oh, by the way, you're going to have to da-da-da-da-da. And I thought, oh, well, I didn't know that. So again, knowing what the code actually says about what all these things need to be made. The landing on the interior side needs to be this high. The landing on the exterior side needs to be not more than this high, Steel masonry lintels bear at least 4 inches on each side and are painted to resist corrosion. This is just stuff that you should just know, oh, this needs to be done. Are you going to make sure that this is done? Whose job is it to do that? Is it going to be painted before you put it up there? Or are you going to paint it after you put it up there, which might not work as well? Does it come pre-painted? Can I buy that? So that I don't have to worry about the risk of what if they didn't get to it the morning that they install this stuff. By the way, on my own concrete pour day, I had worked so late into the night on the foundation prep the night before that I slept in, and the guy knocked on my door of my tiny house and was like, everybody's here, we're ready to go. And I had to literally leap out the door. Concrete truck is all set up. They're ready to go. So there's no time to check anything or to do any checklists at the moment. You got to do more prep. A drip edge has been provided at eaves. Again, this is not necessarily a framer's job, but it affects the framing. So you want to make sure that all this stuff is in. For masonry construction, weep holes have been provided every 33 inches. Also, a lot of this stuff is during a framing inspection. They're inspecting a number of different trades. Like obviously they're installing the masonry trade, which is a different team that's doing the framing. And so they're doing multiple checks of things at one time. So the deck is positively attached. The deck materials are decay resistant. And if you're going to get deck materials that are decay resistant, you need to make sure that the fasteners or hardware are graded to be put into materials that are material resistant. If you didn't know that you can't just use regular galvanized screws or galvanized nails on pressure treated wood, you have to have hot dip galvanized, or you have to have stainless steel, which is super expensive. That kind of thing. Like, the framers all the time, they've got a nail gun, practical speaking. My nail gun, and I've got my bucket of nails that's on my hip, and I keep reloading. If I go from non-pressure treated wood to pressure treated wood, do I literally am I going to put my stuff down and be like, oh, I have to go get my other thing? Or am I just going to be like, oh man, I'm in a groove, I want to keep on going. And did I even notice that I switched over? And now I'm just using the wrong nails. And this happens all the time. Again, so, making sure you have that conversation before. What kind of nails are we going to use over here and what kind over here? And it's like, okay, everybody knows that I know that this is supposed to be happening. Blah, 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 blah. Okay, so guards of handrails, right? So the slats that are between the handrails cannot admit a 4-inch sphere or a 6-inch sphere. What is that? That's a kid's head, is what they're trying to protect against. So when you think about the intent of this stuff, it might be like, oh, well, I was thinking about doing glass anyway, but then, glass is going to be a lot more maintenance and cleaning, but then da-da-da-da. This kind of helps also with the value engineering when you get to there. Framing for the interior. Doors from conditioned spaces to unconditioned spaces are weather stripped and insulated to a level equivalent to the insulation on the surrounding surfaces. This is not about doors. This is about hatches into crawl spaces or attics. And what they're saying is, I want to see the same amount of insulation in the surface that you're interrupting on the backside of that hatch. And this goes for regular doors too, like little dwarf doors that you'd have. You want to back that thing with insulation so that you meet that. Let's see. Pull-down stairs have been installed according to manufacturer specifications. And this according to specifications thing is so important. I say it all the time, and people know this, but it's hard to remember sometimes when you're like dealing with people and you're like, oh yeah, they're professionals. Like I've talked with them and they know what they're doing. People do not want to read the manual. If I've messed with this before and then I'm like, oh, well, this is the same size and shape, I'm just going to use what I know about that to do this instead. That's your incentive always. You don't want to like take time to sit down and read the thing, especially when you're in this trade. Like we just don't spend a lot of time slowing down, breathing, thinking, reading. That's a very big pace change for most people. Smoke alarms are hardwired. Carbon monoxide detectors, same thing. Individually tested. This is not something that happens in the factory. They do not individually test these smoke alarms and carbon monoxide detectors. You do that on site. So are they going to do it? Are you held responsible for that? Again, if you're going to get an estimate from a contractor, whatever trade, that's one page, who knows what, like they're not telling you. I saw an HVAC bid recently that was like, okay, we're going to give you this brand equipment, single stage, whatever, ductwork, grills, thermostat. And it was like, what are we talking about? I mean, there's so many things to talk about within those. So again, have the conversation. Let's move on. The last checklist that I'd like to show you is spray foam. And this is a particularly important one because this is something that can go very wrong very fast. So, contractor-client communications checklist. Guide to professionally installing high-pressure 2-component spray polyurethane foam insulation. By the way, all spray foam insulation is polyurethane. If they say it's, hemp or soybean or palm or whatever it is, that's very nice. It's in there, but there's also polyurethane. So everything is within this. These are generally a truck that pulls up to the house, and it's got specialized equipment in it that puts the stuff in, and it's being mixed inside the gun. I have a giant interview with Spray Jones on this channel that if you haven't seen, I'm linking it on screen right now. Okay, this checklist provides professional contractors and clients, including homeowners and other building occupants, a set of topics to discuss Like, I love that they put this in terms of like, let's just have a conversation about this right up front. There's no points on this one. It's like, hey, let's just make sure that we have something to do with all of these different items. So this is a voluntary aid to protect against potential risks from SPF, spray polyurethane foam. And also, so important that anybody who is involved with foam, spray foam, knows that there are risks. If they say, oh, it's so overblown, there's nothing wrong with this, nothing ever happens, they are lying to you. This stuff can really mess your house up, and it can mess your life up and your bank book. And so take this very seriously. This is a tool, and you should consider it as a material that might be right for your project. But if you're going to use it, go into it with open eyes and know that like this sometimes screws people's houses up pretty bad. So you want to make sure you choose somebody who knows these things, who has these certifications, things like that. So brief description of work, locations where it's going to be installed. They should go out to the house and look at it. Include on this report the manufacturer of the foam that you're using, the product names, the system numbers of the spraying machine, the seasonal blend that you might be using on this particular day, and the lot numbers of like when this thing was produced and what batch it was part of. What its expiration date is on the barrel. The barrels come with an expiration date printed on it. You can walk out there and take a look at the barrel and be like, oh, hey, this thing is past expiration. Is it because I am not, like, did I ask for a discount or something like that you like then were like, oh, well, we'll figure out how to give you a discount. Accreditation, training, and certification credentials. We're going to go over specifically what those are in a minute, but these are very important things. So SPFA, Spray Polyurethane Foam Alliance, gives credentials. Center for Polyurethanes Industry, CPI, Air Barrier Association of America, ABAA, or Building and Performance Institute. That last one, I was pretty certified by BPI at one point, and I don't think that they have something that I would be like, oh yeah, you definitely know what you're talking about, because I've been certified, and I would not be a good spray foam installer with the knowledge set that I have right now. So potential health and safety hazards of all chemicals and processes that are part of the SPF installation. We need to review labels, safety data sheets, material data sheets, safety data sheets and material data sheets, and technical bulletins all might have like information that's like almost getting you to where you need to know. But often the manufacturers don't want to tell you everything for some reason. So they might not tell you exactly what ingredient you might be looking for. And that is an issue that has been talked about. So manufacturer recommendations and installation instructions. This should all be pretty transparent. And again, it's sometimes not as transparent as you'd like to be. Plans to restrict access and wait times before you safely reoccupy the zones. It is not safe for anyone to be in a home where spray foam is being installed without some serious equipment. The guy who's installing this stuff has a full body Tyvek suit and actually positively pressurized. They're pumping air into the back of his suit. He's got a big helmet on. He's not touching or breathing any of the stuff that he's putting on. And everybody else in that space should be similarly equipped because this stuff is like not a joke. In Canada, they do a little better, I think, about this regulation. Ventilation strategies while you're installing, right? Same as like if you're doing a mold or a lead or asbestos remediation, you want to make sure that you're depressurizing certain places, pulling the air that's being contaminated to some place that you know there's not people. Long-term ventilation discussion. I love this. They're talking about like you have to discuss what you're doing with the enclosure with your HVAC design professional, who might be the HVAC installation professional, but it also might be a different person, because we have to build in actual ventilation, assuming that this thing is going to be airtight when you're done, pretty airtight, which it definitely could be. Environmental conditions needed for foam installation, like air and surface temperature, humidity, surface moisture. Those are all so important. How are we measuring those? Again, what instrument are we using? When are you going to do it? Are you going to do it first thing when you get there in the morning? Are you going to do it in the morning, again at lunch, again in the afternoon? What if it starts raining at 1 o'clock? Did we are we just going to keep on going? What's happening? So these kinds of conversations really, really so important in this particular style of work. Okay, during and after application, make sure you do not return for a period of time after. They say down here, 24 hours application wait time is generally kind of considered to be the norm, but recommended time may vary. There might be a particular product that we're installing that wants you to use a 2-day return, a 48-hour window. Take those seriously, because the spray foam insulation is going to continue to cure within that window, and then it'll be done at some point, hopefully. And if it's a bad mix, which apparently there are machines now that you can use that will monitor the mix for you. So there's like quality control that can be built into the technology that's delivering this, which is good. But I'm sure that there are ways to bypass this if you're just like, man, I just got to make this money today. Okay, so all of these I think are just so fun and useful. And if you're getting this master's degree in YouTube, then this is an really easy extra credit that you could be doing on the side just to make sure that you have as many pieces of information as possible. As always, please comment below if you have other things to add, other checklists to recommend to people, questions to ask, things like that. Like and subscribe. Tune in next time.